Hello friends, welcome to AI's live session on KPTCL Public Sector Unit Exam Preparation Strategy and some of the model questions. Myself, Sriram, working for AI's Engineering Academy since 2014, and I here teach digital logic design. Today we are going to discuss one of the simple topic in digital electronics or digital logic design, such as logic gates. Why I have selected a simple topic in the subject? Just to make everyone understand, because some of you guys might not start the preparation yet. Even some of you guys might be started the preparation, but everyone has to understand the questions pattern in the KPTCL and how they are asking the questions and how they are framing the questions from each and every topic, and how to prepare, as it is completely different from other public sectors and gate preparation. Even majority of the times questions are majority of the times the similar questions are taken from the previous gate exams, 1 mark questions. But this exam pattern is little bit different, because not only from the given syllabus or observed syllabus from the previous year questions, we can expect some questions from out of the syllabus also, so that we need to prepare mentally, right? And see, this is just an initiative to start the preparation, but you need to do the hard work. You need to make your own plans for the preparation, right? And generally, once if there is a notification, generally most of the times students will search for the preparation strategies, or they'll call the faculties and they'll ask the preparation strategy. No, simple. Let me give you a simple story about the preparation strategy here. If you could able to dream your success, you can see the preparation strategy on the word success. Like that, I want to give you just 2 minutes of information about the preparation strategy, right? And I want to give you some definition for each and every word of success. It's nothing but our preparation strategy in a simple and different way. And one more important point. In order to succeed in competitive exams or public sectors, especially like KPTCL or maybe Genco, Transco and some Discom or some other public sectors like ISRO, you don't require rocket science. We don't require rocket science. We need some dedication. We need some interest, patience, and some clarity about our goal. These things, and little bit hard work along with smart work. These things are sufficient. If we have proper plan, these things are sufficient to get succeed in public sectors. And see, the first letter of success, strategy. What exactly the strategy? Planning and execution. We might have not many number of plans in our mind, but only problem with each and every person is execution. You prepare some plan, but do execute it. You prepared that. You have a schedule. By this weekend, I need to complete EM theory and emissions, 2 subjects. Parallelly, like simultaneously. Yes, we need to start it. You need to start the execution. And every 10 days, you keep on change the strategies or keep on change the what we call schedule, no problem. But at least we need to follow up the schedule what we have prepared. So this is simple. First word, strategy, planning and execution, right? Please don't separate them, right? And understanding. You need to repeat only the complicated topics. You need to revise only the complicated topic. Repeat and revise complicated topic. What is the cut-in voltage of silicon diode? 0.7 volts. It will be there in the option. Not only you, anyone can answer that question. If you feel some topic is typical, complicated, no doubt everyone will feel the same, you know. So you need to focus on those areas because it is a competitive exam. So you should know on which topic we need to spend more time. So that is nothing but the understanding. You need to understand not only simple things, the complicated things also, complicated topics also, right? And clarity. It is not about the subject, it is about you, it is about your mindset. Where we are, what is the syllabus? For what exam we are going to prepare? Okay, let us say KPTCL or some other Genco, Transco, some other public sector. What is the syllabus? What are the previous year questions? How the examiner framing the questions, whether they are copying the 1 mark gate questions or ESC questions, or they are creating any new questions, or they are like focusing on some questions from the standard textbooks. You need to have your own clarity. What are the subjects, topics, subtopics, importance of those topics, weightage of the subject wise, topic wise, how many topics are completed yet, and what is the leftover time, and how to plan to complete the rest of the things. This is the full clarity you need to have. If you have the clarity, no doubt, you looks like energetic person. Means that is called confidence. Without these three things, if you feel you are very strong, that is overconfidence. But if with these three things, if you feel, yes, I am very strong, that is nothing but the confidence, right? And enhance. What is the difference between you and your friend? What is the difference between you and others? Yes, enhance the subject, enhance the knowledge, concept. That will make you different from others. Simply in simple terminology, PSU preparation means data collection. We need to get more data. If you come for the coaching, not only you, thousands of people also will get the same content given by the faculty. Then what is the difference between you and others? You need to have some more information. You should collect the data from some standard textbooks, previous year ESC papers, gate paper, 1 mark question, some public sector unit, Xor papers are available in internet. And you can go through the Google, like you need to just do Google and search some of the information, the qualitative information, add it. You need to enhance. You need to think about the question format. You must be in a position to create some objective questions. Then automatically you can understand the questions given by others like examiners. Right? And smart work. This is very much needed, especially for some non-technical topics. Not only reading, like morning to evening, if you keep on read, if you could able to understand only 10%, what is the use? Do smart work. Hard work is okay, but I don't believe that only hard work people will get success. Along with hard work, you need to do some smart work. What exactly the meaning? You prepare the formula sheets, short notes. The entire subject should be in 5 pages. In 10 minutes, you should revise everything. All key points, bullet points. Like that, you prepare short notes. You write formulas on one sheet, stick on wall. Do some smart work. You record some formulas. If it is non-technical content, you record that content. In free time, you can enjoy that content. Right? So like that, you should recall. As it is, audio tape is available with you. You can recall everything. Right? So that is, in that way, you need to do some smart work also. That is very much needed. And generally some students will try to get everything at a time. Highly impossible. How can you study, complete one topic, and how can you solve all the related problems in one day? Spend some time. Right? Please do not try to get everything within 1 day or 1 week. It takes time. You give time for the brain to digest the new things, new subjects. Pattern of the exam. It has to understand the pattern of the exam. So that is our responsibility. We have to give feeding to the brain and give the training for our brain. Then we can automatically will be flexible for any competitive exam. There will not be any fear before going to the exam if you go with a proper plan. That means what I am saying, you better to follow like slow and steady mode. Please keep your mind in slow and steady mode. Please do not keep it in fast forward mode. It will not work out. Right. And my dear friends, so simply if you take this, say now onwards, if you see, it is your dream, no doubt. And your dream will definitely comes true. But if you see that success, now onwards, if you see what is behalf of this success, there is your dream. But on the name of the success, each and every word will give you strategy. You don't need to ask the strategy. You don't need to search the strategy in internet or somewhere. Right? Okay. And coming to the digital electronics, we know in KPTCL, there is no standard pattern for the syllabus, but these are the topics we just framed out the syllabus based on the previous year questions and based on the importance of the topics and their linked topics like number systems, Boolean algebra, Karnataka map, logic gates, combinational and sequential circuits, analog to digital and digital to analog converters. Majority of the times, actually, do not give the priority for 1 and 2. You need to go for the total topics. But majority of the times questions are found from Boolean algebra, K-map, ADC, DAC and counters part of sequential circuit. In sequential circuit, there are so many topics, flip-flops, counters, registers, but in the counters part, modulus number of the given counter. This type of questions are found. Yeah, coming to the topic. See guys, logic symbols and their operators. This is generally called as exclamation mark. Generally we are using operator point of view. We are using exclamation mark for not operation. I think you can see this dot is generally preferred for AND operation, plus sign is for OR operation. This is NOT gate. Just you recall these things, basic things only. AND gate, OR gate, exclusive OR gate. We'll discuss one by one. Exclusive NOR gate, NAND and NOR gate. So these are the operators. By looking at the operators, we can understand operation of that particular logic gate. It is also called as IEEE symbol of these respective logic gates. And we are using this symbol for exclusive OR and exclusive NOR, but we don't have separate specific symbols for NAND and NOR because it is just combination of AND plus complement and OR plus complement. Now, see, I am assuming A is the input and A bar will be the output obviously for a NOT gate. But don't underestimate any topic, any subtopic. It's look very simple. Sir, NOT gate, complement of input, okay. But I will give you, we'll solve some questions. There you can realize, okay, with simple NOT gate also they can frame basic level to complicated level questions. But I cannot solve here the 2 marks questions because it is intentionally the session we have started for public sector. So we need to focus on 1 mark questions, okay? Right. So just it's a complement of input. Output is nothing but the complement of input. 1 complement 0. And it is OR gate. Let me take some variables A, B. Obviously the operator is A plus B, OR operation. If any of the input is 1, output can be 1, otherwise 0. We'll go for the switch equivalent model of these circuits just little later down the row. And this is the AND gate. A and B are the input variables and the operator is A dot B. If any of the input is 0, output can be 0. It will produce a logic 1 at output only when all the inputs are logic 1. NAND gate, AND operation plus NOT operation. NAND gate. AND with complement. So if any of the input is 0, 0 and anything 0, its complement is 1. So 1, 1, 1 and 1 and 1, 1, 1 bar, 0. NOR gate. OR operation along with its complement. If any of the input is 1, 1 plus anything 1 and its complement is 0. If any of the input is 1, output will be 0. But if both the inputs are zeros, 0 plus 0, 0, its complement is 1. Yes, very important. Logic gate, exclusive OR gate. A and B are the inputs and output Y0 is equals to symbolic representation A XOR B, or we can write the function A bar B plus AB bar. A bar B plus AB bar. If inputs are complemented to each other, you can verify, substitute and verify, it will produce logic 1. If it find the same inputs, I'm talking about 2 input XOR gate only, please. In this session, I can cover only 2 input XOR and XNOR gates. 3 input XOR are multi-level, are multiple inputs, XOR and XNOR with multiple inputs. That story is completely different. First, we'll discuss only 2 input XOR gates and their combinations related problems, right? Outputs will be 0 and 0. And actually, the XOR and XNOR gates are also called as arithmetic gates. See, my dear friends. See, these 3 gates can be called as basic gates. Basic gates. You know that NAND and NOR gates are called as universal logic gates, simply universal gates, because by using either only with NAND or only with NOR gates, we can implement any other logic gate. What it means? The entire digital system, it may be either combinational or sequential circuit, that module can be implemented by using only with NAND and NOR, because we are having their own importance in the universal design. That is a different story. I think it might not be covered in this session. It's a long story, little bit a lengthy topic. And these 2 gates, you might be studied as, in academic years, you might be studied as like derived gates. Of course, may be correct, but indeed, you should call it as arithmetic gates. Generally, we are using them in arithmetic operations. These 2 gates plays vital role in adders and subtractors and the entire arithmetic circuit design in combinational circuits. So these 2 gates are generally called as arithmetic gates. Arithmetic gates, right? I will give you the basic operations of XOR gate after completion of XNOR. Actually, it is also called as OR gate. XOR gate is also called as OR gate. XNOR is a even gate. Remember, I'm talking about XOR XNOR with 2 inputs only, 2 inputs case. See, if you observe carefully, my dear friends, for odd number of inputs at the input, output will means odd number of ones at the inputs, odd number of ones at the input, it will produce logic 1. Single one and single one, output is 1. Even number of ones, output is 0. Sir, here we have only zeros, sir. Yes, zeros. It means no ones, 0 ones. We need to talk in terms of like binary only. Okay, right, 0 ones, even number, right. So for odd number of ones at the input, it will produce logic 1. Of course, irrespective of number of inputs, XOR gate properties remains the same, but XNOR gate property is different for 2 inputs and 3 inputs and different combinations. Okay, I don't want to touch those complicated areas now. I want to give you the basic idea and with which we can solve all related questions very easily, right. And it is an OR gate, you know, exclusive NOR gate. It is just a complement of XOR gate. exclusive NOR gate, just complement of XOR gate, AB. A logical symbol is A like this, Xnor B, and the expression AB plus A bar B bar. It is also called as, of course, it is also called as coincident gate. Why? Because you can substitute the input combinations to get the output. If inputs are same, like 0, 0, 0 bar 1, 0 bar 1, 1 plus anything, 1 plus anything, 1. Output can be 1. Even 1 into 1, 1, 1 plus anything, 1. Other than that, it will produce zeros. So, if A is equals to B, you see, my dear friends, output is 1. So, whenever the coincide or coincidence is occurred at the input, this particular gate is going to produce logic 1 at the output. That is the reason we can also call it as coincident gate. And it is also called as even gate. It is also called as even gate because for even number of ones at the input, output is logic 1. Output is logic 1, right? So, XOR gate is an odd gate, 2 input Xnor gate is a even gate. XOR gate, 2 input or 20 inputs. Operation will not be changed, but Xnor is different. As I am not going to discuss it, you remember 2 input XOR odd, 2 input Xnor is acting as what? Even gate, right? Even gate and coincident gate. Coincidence gate. XOR and Xnor, some of the operations we can use them. See, just observe the truth table, my dear friends. Let me take this XOR gate. Just observation, no need to by heart anything. Try to use less memory but more logic. Let us say this is A or X, let us say it is X, one input is X. One input of XOR gate is permanently connected to ground. This is the most common question you can find in ESA and some of the public sectors. What is the behavior of the logic gate? Behavior, you can find the options in terms of logic names, logic gate names. See, my dear friends, if one input is 0, like one input is grounded, whether A or B, whatever, no problem, you can try it. What is the relation between next input and output? Next input, if A is permanently, this is a XOR gate. This is a XOR gate. In exclusive OR gate, what I wrote, if inputs are complemented to each other, it is producing logic 1 at the output. If inputs are coincide, I mean same, what is output? 0. That is a basic truth table. That is a basic truth table. But if one input is 0, then what is the relation between next second input and output? See this. Input 0, output is also 0. Input 1, output is also 1. So, I can say it as a buffer. I can say it as a buffer. It is acting as a buffer. Immediately, you can laugh at this, sir, what are you talking? Instead of using this logic gate, why don't you use a wire? Yes, generally we are using this type of buffers in combinational circuits to switch the circuit operation from adder to subtractor and vice versa. There are so many applications found for this logic gate like XOR gate in this programmable buffer, programmable buffer operation. And moreover, it is not only transmitting the signal, it will produce some time delay. We need to use, in most of the designs, we need to use some specific time delay for the data. Wire cannot hold the data for some time, but this logic gate will hold the data for some time. That is called propagation delay. Just we'll discuss little later, right? So here, whatever may be the story, if one input is ground, XOR gate is acting as what? Buffer, that's all. Immediately you should ask me, sir, if one input is connected to 1, ground means logic 0. If you connect one input terminal of XOR gate to the logic 1, whatever may be X, Y, Z, whatever, if it is connected to 5 volts or logic 1, it acts as inverter. See, my dear friends, 0 input, its complement is 1 output. 1 input, its complement is 0. So, if one of the input is 1, the XOR gate, acting as what? Inverter or NOT gate. It is just behavior, okay? It is just inverter, you write, or NOT gate. And similarly, Xnor Gate. Let us say it is a Xnor Gate, right? This is ground. It will act as A bar. I don't give more explanation because you know the procedure. If one input is 0, 0, 1, 1, 0. Output is complement of input. It is acting as NOT gate or inverter. X, A, Y, whatever you want, just. It acts as buffer. It acts as buffer. So, here you can write, can I write like this? A Xnor 0 is equals to A bar. A or X, whatever. Xnor 1 is equals to X. X, Xor 0, one input is 0, buffer, X. X, Xor 1, one input is 1, inverter, X bar. Inverter or NOT gate. If inputs are same in Xor gate, what is the output? Have you remember? 0. A Xor A 0. A Xor 0, if one input is 0, acting as buffer. If inputs are complemented, that means one input A, next input A bar, one input 0, next input 1, one input K, next input K bar. What is the output? 1. Have you remember this? If one input is 1, it is acting as a inverter. Otherwise, you can substitute the values. A Xor 1, you can substitute the values. A can be either 0 or 1. 0 Xor 1, 0, this is A 0, substitute A value. 0 Xor 1, what will be the output? 1. 1 Xor 1, 0. Whatever the A you are going to substitute, that will produce its complement at the output. You watch the video carefully, write the notes, you will get the clarity. But if you already started the preparation, you can easily follow it, because I want to go for the problematic part by completing the basic idea, just a basic idea, right? And even we can write A bar Xor 1, you just bring this side, that's all, is equals to A. You can verify this with the help of truth table. A bar Xor 1 will gives A. This is all about Xor basic operations. Similarly, Xnor gate. A Xnor, inputs are same, coincident, output is 1. A Xnor, you write 0 or 1, no problem. A Xnor 0 is A bar. If one input is 0 in Xnor gate, it acting as inverter. A Xnor 1 is equals to, one input is 1, acting as buffer. A Xnor 1 is equals to A. Inputs are complemented to each other. It is dot, okay, it is dot. A Xnor A bar. If inputs are complemented to each other, not same, output is 0. So from here we can write A Xnor 0 A bar, see already I wrote, A bar Xnor 0 is A. A bar Xnor 0. A bar Xnor 0 will be A. If you want, you can write it. You can verify by taking the values. You can just go with the trial and error method. You can test by substituting the values. It can satisfy LH and LHS and RHS. Okay. Yeah, before entering into the problematic part, see, what is the propagation delay? I want to explain in a very simple terminology. Rather than by link up with hold time and what we call setup time and all. Simple, very propagation delay. It is an average time delay provided by a logic gate or a circuit to propagate the data from input to output. In other words, it is a time delay between excitation and response. Simple way. Time delay provided by that logic gate or circuit between excitation and response. Or it is actually average propagation delay produced by the system or circuit or logic gate to produce output after excitation, right? Or for the data transmission, right? Generally, this is very less. Ideal case 0. If examiner not provided anything, you can assume it as 0 seconds. You can assume it as 0 seconds. 0. No need to worry about it. But practically it is in the order of picoseconds to nanoseconds. In problematic you can find microseconds also. On paper you can write anything, but practically it is in the order of picoseconds, right? Okay. And generally we can represent the propagation delay with some symbols, delta. Or you can directly write TPD or TD, simply time delay. The behavior of the circuit. See, a stable multivibrator, you write it, MV stands for multivibrator. Bistable multivibrator, monostable multivibrator and comparator. Okay, well, what is the behavior? How to understand this type of circuits? But please remember, whatever the explanation that I am going to give you, that explanation is valid for this type of systems which is having closure loop like this. Closure loop. We are not going to represent power supply. Internally it has power supply, you know well. Simply if I hold the NOT gate here, if I assume 0, I cannot get 1 at the output. It has internally some power supply, we are not representing it on IEEE symbol, right? So, how to solve this type of equations? Very simple, by taking some assumption. We need to take some assumption. Just for explanation comfort, I placed one extra slide here. Whatever you want, you can assume either 0 or 1. For example, if I assume 0 here, its complement is 1. But you should assume that while doing analysis for this. In problematic part, they will provide, you don't need to worry. This logic gate, each logic gate is providing some time delay, propagation delay. Let us say it is TPD, just TPD, right? After some time delay, as I assumed 0 here, output of this first logic gate will be logic 1. And one complement here. One complement is 0, 0 complement is 1. Yes, very simple, sir. Yeah, of course. But my dear friends, output, actually the new output, what was the past or assumed output? Sir, we did not assume anything, sir. No, we have assumed something. See, this is wire only now. As this is 0, as we are assuming it as 0, that means initially I am assuming this output is 0. Now it is appeared as, after some time, it is appeared as logic 1. It is going to change to logic 1. So, this 1 is a new input for this system. Just repeat the process. New input is 1 and its complement is 0, 0 complement 1 and 1 complement. After some time again that 1 is going to be 0. What it means? Output is not going to stable. It is keep on changing. Sir, what next? You know well. If this is 0, no need to do. Already we have done this. By assuming 0, what will happen? After TPD, this is the propagation delay. TPD, providing by logic gate, selected logic gate. TPD, TPD, TPD. After 3 TPD, again output will change from 0 to 1, 1 to 0. That means, what is output? Output is a square wave. Of course, we can call it as square wave generator, also called as ring oscillator, right? So, we are getting some square wave at the output. How the examiner can frame the equations on this? Very simple. Generally, they can ask you the formulae, but some rare cases they can give the numericals. As there is some waveform, we need to find its frequency. What is the general formula for frequency? F is equals to 1 by time. What is the total time? You need to consider total cycle, one complete cycle is equals to 2 half cycles, so on time and off time. T is equals to on time plus off time. Sir, what is on time and off time here? Very simple. Very simple. This is the total time. You can start from here also, no problem. This is the total time. This is on time and this is the off time. Sir, what is on time? Assume just this is a point. This is a point where the output has been switched from 0 to 1. See, output has been switched from 0 to 1. Just assume. Now, new output is 1. Assume new output is 1. How long this 1 can be present at the output? See, wire delay, nothing. See, this is 1, right? Look at this line. 1 bar 0, 1 TPD, 0 to 1, 1 TPD, 1 0, 1 TPD, 1 plus 1 plus 1. After 3 TPD, 1 is going to be changed. Like 1 will be flip. How long? That means it is simply 3 into TPD. 3 into TPD. We can also call it as path delay or n into TPD. On time is equals to n represents number of logic gates. 3 into TPD or n TPD. N TPD. What about the off times are same? See, just observe the delay the moment you change the output from 1 to 0. Output is now, present output is 0. How long that 0 will be present? Same path, 3 TPD. So, on time is equals to off time. That means total time T is equals to 2 into n TPD. So, what is the formula for frequency? I am writing here. F is equals to 1 by 2n TPD hertz. This is the formula for frequency of square wave. What is the behavior? See, there are two states at output. It is a square wave generator. Now, how many states are there at output? 2 states, right? Logic 1, logic 0, logic 1, logic 0, logic 1, logic 0. Only 2 states that just keep on switching. Which one is the stable state? Can you guess? Which one is the stable state in the output? Logic 0 is stable or logic 1 is the stable? Which one is the stable state? Neither. Neither 1 nor 0. Because that output is keep on changing. No one is stable. No stable state. Given is a stable multivibrator. It is also called as what? Not only square wave generator, it is also called as stable multivibrator. Given is a behavior of circuit. See the background. Question, answer, very easy. It's look like a theoretical question, but the student who know the background, who know the fundamental, they can feel it is easy. Otherwise complicated or out of syllabus. Our mind will say out of syllabus or complicated. But if you prepare, if we have touch with the fundamentals, it's very easy. Okay. Frequency F0. Please you write F0 here. F0. Propagation delay is 10 microseconds. 10 microseconds. F is equals to 1 by 10 into, 2 n TPD. 2 into 1, 2, 3, 4, 5. N into 2n into TPD. What is the TPD? 10 microseconds. 10 into 10 power minus 6. You do the calculation. You will substitution only. Just it's a matter of substitution. You will get right. And now try to guess the answer. I am expecting the answer. You try to get the answer here. See, Find the frequency of waveform at f0 if the propagation delay if each logic gate is 2 microseconds. Propagation delay is 2 microseconds. Generally, students will start f is equals to 1 by 2 into n into TPD. F is equals to 1 by 2 into, what is the n? 3 plus 3, 6. You will get some value. But the answer is, sir, in the previous problem you have taken output from here. Wherever you want you can take it. No problem. See, my dear friends. Here you take the output. Here you take the output. Or here you take the output. This is also a point where you can take the output. Happily, no doubt. You will get the same answer because it's just matter of readjustment of logic gates. See, if I take the output from here, it is just wire. You can extend this wire. See, what will be the circuit? Remains the same. Remains the same. So the operation remains same. At any point, the output frequency or frequency of the waveform remains the same. F is equal to 1 by 2 into n into propagation delay. Okay. So, in that way, generally students will try this. Okay, sir, then we can do F is equals to 1 by 2 into n into TPD, n is equals to 6. You will get some numerical. You test yourself. I think if you are in live, you try to solve it as fast as possible. Or after uploading the video, if you are watching this, you pause the video and do it and verify your answer. The answer is 0 heads. That formula will not work for this problem. We cannot use that formula for this circuit. Sir, why? Why? Because, my dear friends, this formula is valid for S-stable multivibrator only. S-stable multivibrator only. 1 by 2n TPD. S-stable multivibrator only. Sir, what about this? This is not S-stable multivibrator. I'd like to explain it with one simple circuit. This is a modified circuit. See, I took a circuit with only 2 NOT gates. Yeah, let us start the analysis. Let us assume the input is 0. Sir, why don't you take 1? You take 1, no problem. Right. 0 complement 1 and 1 complement 0. What is the feedback? What is the new input, guys? 0 only. There is no change at the output. Sir, if I assume 1 at the input, 1 complement 0, 0 complement 1, same. It will preserve the same value as it is not being changed. It will produce a DC line, you know well. Frequency of DC line is how much? 0. How many changes are, strictly speaking, how many states appeared at the output? 2 states. It depends on your triggering or your assumption. Yes, there are 2 states can produce by this circuit at output, logic 1 and logic 0. Logic 1 and logic 0. And both are stable, my dear friends. Once if 0 is fixed, as time t progress, it never be changed. Once if you get 1 at the output due to whatever may be the excitation or feedback, if you find 1 at the output, as time t is progress, it will not be changed. It will be fixed. That means any logic, it can be fixed, no change. That means both are stable. Both are stable. 2 stable states. Bistable multivibrator. This is not an stable multivibrator. This is a bistable multivibrator. So, remember, for a bistable multivibrator, the output frequency F0 is always, no formula, direct answer, 0 hertz. But sir, every time we need to do like this? No, simple technique. My dear friends, if you find odd number of logic gates in the closure loop, I repeat, in the closure loop, okay? Odd number of inverters, logic gates in the sense inverters only. Maybe NOT gate or maybe some other gate programmed as inverter. Whatever, but it should be appeared as inverter. So, if odd number of inverters are connected in closure loop, then you can use it as a stable multivibrator or square wave generator, also called as ring oscillator. I have explained. We can call it as S-stable multivibrator, odd number of inverters. It is an S-stable multivibrator 1, 2, 3, 4, 5. But 3 plus 3 is 6. It is a bistable multivibrator. No formulae. Direct answer 0 hertz. Bistable multivibrator 0 hertz. It is just information to enter into the problems. See, because it can help us. If you could able to remember some of the basic conversions, we can simply skip these type of things in the complicated questions, right? A XOR B, XOR operation. F is XOR gate. F is actually output of XOR gate. What is the complement of A XOR B? A bar B plus AB bar. By look at the circuit itself, we can understand. XOR gate. If you take bubble Xnor, that means XOR two input case. XOR Xnor complemented to each other. Let me prove it. It is XOR operation F bar. Let me take its complement is equals to apply De Morgan's theorem. We should know that De Morgan's theorem at least. Of course, you people may be aware of that. Let me take x dot y whole bar. You can write it as x bar plus y bar. X plus y whole bar, we can adjust it as x bar dot y bar. A bar b whole bar dot a b bar whole bar. A double bar. Again apply De Morgan's A double bar plus B bar. Double bar means simply A. A plus B bar dot A bar plus B. And my dear friends, I hope you may know the basic idempotent rules of Boolean algebra. A dot A is equals to A plus A is equals to A, 1 plus A plus anything is equals to 1, A dot A bar is equals to 0, A plus A bar is equals to 1. Actually, these things will be covered in a separate unit, a topic called Boolean algebra, right? Boolean algebra. These are some idempotent rules. Okay, A into A bar 0, AB, B into B bar 0, B bar A bar, that is nothing but A bar B bar. So, given is a Xnor gate. After every, see, you are preparing some topic. After, at the end of every concept, maybe simple or tough, no matter. But you need to do your work. That is called discipline. I have explained in the introduction page. We need to follow protocols, that's all. We need to write the observations. A XOR B complement is equals to A XNOR B. Similarly, you can test it. A XNOR B complement will give A XOR B. F is equals to A XOR B XOR AB. Okay, try this problem. You will get A plus B. We'll continue in 3 minutes. Just 3 minutes break. right? It is XOR operation, we can separate it. Actually, these fundamentals will be covered in Boolean algebra. Just if you know the commutative law and associative law, with which we can understand how we can separate this. But just follow A XOR B, we can separate it as per our comfort, that's all. We can select any two variables, no problem in XOR and XNOR operations, in the equations, right? So, I am assuming it as X and this is Y, simple. X, Y, XOR operation, X bar Y plus X Y bar, that's all. So, what is the F? X bar. What is the X? XOR gate. Its complement XNOR. AB plus A bar B bar. So, X bar Y. What is the Y? AB. Plus X Y bar. What is the X? XOR operation. A bar B plus AB bar. Y bar AB bar. I mean X Y bar. So, F is equals to AB plus A bar into A0. See, to minimize the number of steps, I am writing here only. A bar B bar, I can write it as apply De Morgan's theorem. A bar plus B bar. So, A bar into A bar B. A bar B plus A bar into A0. Next, B bar into B bar A. A B bar. B bar into B, 0, right. F is equals to, see, what is the common term here? B is a common term. B into, have you remember this? A plus A bar. A plus A bar is equals to 1. Simply, I can write it as B plus A B bar, A B bar. It is a direct relation called redundant literal rule. You might have studied like this. A plus A bar B can be written as A plus B, as per the redundant literal rule. A plus A bar B can be written as A plus B. So, F is equals to B plus A or A plus B. See guys, n number of inverters are connected. Inverters. Sir, how do you know? You know that this is what we have discussed. If one input of XOR gate is connected to logic 1, it acting as what? NOT gate. What is the output after first NOT gate complement of input? X bar. What is the output of second one? Complement of input. X bar complement is what? X. X bar complement is X. Sir, do I want to write till 1947 number of gates? No need. After odd number of gates in this series, odd number of gates, output is X bar, and after even number of gates, output is X. So, 1947 number of gates, odd. So, you know the output. After odd number of gates, what is the answer? That is the answer after 1947th gate. That's all. Like this, you need to understand a pattern of the circuit and continue with that. Or sometimes they may connect one here, X here, or here X or A, whatever, and it may be 0. Like that, you need to prepare some questions. Very interesting and simple question. By look at this question, generally students will start doing operations, XOR gate, XNOR, I know everything. No, you need to use like some smart brain here, right, rather than the complicated things. If you observe carefully, my dear friends, this is A, B bar C are the input for first XOR gate. A, B bar C, C B bar or B bar C, you can write, right? So, for second XOR gate also we are giving same inputs. Sir, do I want to write A XOR B bar C, sir? No. you write it as something like x. You write as x. What is a x? B XOR C and A, XOR operation. Because here also you will get the same. Why should write the function like B bar C XOR A? Simply write x. Whatever the output produced by the first XOR gate, it will be copied by second XOR gate. I mean same as the operators, means output operators are same, you will get the same logic like 1 or 0. Right. Now, so what is output here? What is a Z? Inputs are same. What is this? Coincident gate, Xnor gate, right? Coincident gate. So that output is 1. Inputs are same, output is 1 because it is a coincident gate. These two are XOR gates. Of course, a similar model. This is X XOR Y. What is output here? X XOR Y. XOR Y. What is the Y XOR Y? You can separate like that. Y XOR Y, inputs are same in XOR gate 0. If one input is 0, have you remembered 0 XOR A, 0 XOR X, X. So this is X only. Here, I can write X, simply it is X, or it is equals to X. What is output of this logic gate? One input is X, next input is Y. This is X XOR Y, X XOR Y, okay? What about this? X XOR Y, output of second XOR gate, X XOR Y, XOR, look at this, Y. This is Y. X XOR Y XOR Y. Y XOR Y 0, 0 XOR X. This is what? Finally X. What is the second input? Is also X. This is X XOR X is equals to 0. What is the final output? Final output. Please don't confuse. This is not a XOR gate, okay? This is Xnor gate, coincident gate. Can it be coincide? No. One input is 0, another input is something like, you assume it as K, X XOR Y is K. Or otherwise you recall, for Xnor gate, if one input is 0, it acts as inverter. One input is 1, act as buffer. Xnor gate, okay? Right. So it is inverter. It is an inverter. As it is an inverter, output is the complement of second input. What is the second input? XOR operation between X and Y. X XOR Y whole bar is equals to X Xnor Y. Like that you have to solve this type of equations. Just basic operations. It looks like little bit complicated, but no, very simple. All are just, we have selected the questions from previous KPTCL and some public sector, and mostly from 1 mark gate questions. The logic implemented by the circuit. A XOR B XOR AB. This is given in gate, of course, 1 mark bit. A XOR B, see AB, XOR AB. What is this? A plus B. Already we have solved it. Yeah, this one. A XOR B, XOR AB, A plus B. So this is actually acting as what? A plus B, OR gate. Yeah, fine. For the circuit shown in figure, required inputs, input condition at A, B, C, to make the output is 1. He given the output already. Output should be 1, that's all. What should be the inputs? Very simple. Very simple. At any cost, this value should be 1. Am I right or not? Because if it is 0, meaningless. Whatever may be the inputs, output will be 0. But output must be 1, so that all the inputs of AND gate should be 1. Hello friends. All the inputs of AND gate should be 1. Then only output can be 1. That is our target. Okay. I am writing our target first. 1, 1, 1. So at any cost, C should be 1. So for all the options, C is given as 1. Okay. Next. What is the name of this gate? Xnor OK. It is coincident gate. To get 1 here, what should be the next input? Already C must be 1, you know well. C should be 1. To get 1 here, compulsory B also should be 1. That's all. B should be 1. If B is 0, sorry, remove that option, okay? If B is 0, remove that option. For 2 options, B value is 1. And this is not a coincident gate, right? But output should be 1. If inputs are complemented to each other, then only XOR gate will produce logic 1, so that as we know already one input is 1, the next input must be complement of 1. It should be 0. Then 1 XOR 0, it can be 1. A must be 0. See here A is 1. It is overlapped. So please you see D option is 111. Wrong answer. B is 011. A0, B1, C1. A0, B1, C1. That's all. Actually, it's a part of universal gates, but there is a methodology to print so many things in our brain. Are the students who are already prepared, they know how to memorize these circuits for XOR, XNOR, and or not, using NAND and using NOR. There will be one table, and that is a level 1, level 2, level 3, level 4, different combinations. For example, A bar, B, C, minimum number of 2 input NAND gates requires to implement the function. This kind of questions generally, that is one topic actually, universal gates. But we don't know that. Circuit is given, what is the behavior, that's all. Then you know one thing, we know the basics. We know how to operate with ones and zeros for any circuit. So we can do it, that's all. This is A XOR, sorry, AB bar, AB bar. What is the output? Sorry. Small letters, okay? A dot B whole bar. A dot AB bar, again bubble, whole bar is equals to A bar plus AB double bar. I am applying De Morgan's theorem, AB. Similarly, you will get B bar plus AB. So the output is NAND operation between these two. A bar plus AB dot B bar plus AB whole bar. Apply De Morgan's theorem. A bar plus AB whole bar plus B bar plus AB whole bar. Again De Morgan's. A double bar dot, that means A dot, AB bar, AB bar, De Morgan's A bar plus B bar, plus B dot A bar plus B bar. A into A bar 0, AB bar plus B into B bar 0, A bar B. So this is a XOR gate. Sorry, this is a typing mistake. This is XOR. This is XNOR. Okay, and or XOR, XNOR. XOR. You can try this question. You take this question and you take question with the bubble also. In both the cases, you will get the same answer. You try this question. You can do it. output f is independent of x, y, z. For example, if you get output is equals to x, z, that means output is independent on y, like that. You have to select the options. It's a matter of simplification. I think you can do this. This is one of the model. X, I'm writing small letters, you write, no problem. X, y, z. X dot y bar whole bar. X, y bar, and operation and not operation, and operation and not operation. This is y, z. So, f is equals to AND operation. X dot y bar dot yz. You please do this. You will get one option, like you will get only two literals. I mean, output will be like x, y, yx, zx, like that. You will get only, you can find two variables at the output, right? Okay. This is x bar plus y double bar y. After that, you verify into yz. F is equals to x bar yz plus yz. F is equals to yz is common, x bar plus 1 or 1 plus anything is 1, yz common. So, output is independent on x, not depending on x. Only y and z will decide the output. F is independent of x. So, you can do this question. Actually, this is the Xor latch using Nand gates. I think you might have studied Xor latch. Circuit just given differently, but you no need to identify this. No need to identify this. You can do the analysis, use the subject knowledge. Both inputs are 1, 1. Xor, if Xor values are in Xor latch, Xor 0, 0, not allowed. Output is not allowed. If Xor 0, 1, output 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 0, Xor latch using Nand gate, opposite. And if Xor 1, 1, output is previous memory state, or you might have studied no change state, like that. You can do analysis here or otherwise here also, simple. This is 1, I assume output is Q. Q means 1 or 0, whatever. Q into 1 Q, this is Q bar. Bubble is there, no? Q bar. Q bar into 1, Q bar, again bubble. So, Q double bar is nothing but what? Q. Output never be changed. This is nothing but previous state in the truth table of Xor. Xor latch, you might have written like this. Q bar output 0, 0, 0, 1, 1, 0, 1, 1. I am writing answer for 1, 1. No change or previous state. For remaining, this is not the topic here. That is the reason I am not writing. This is not allowed state and 1, 0, 0, 1. But both are same. That is what I want to tell you. But even if we fail to recognize original circuit, we know the fundamentals, you can apply the things and can select the option. This is a gate question. For the circuit shown in figure, direct substitution and observing the outputs. Y is equals to A bar plus, see this is OR gate, okay? C bar plus, what is this? AB bar, and this is BC bar. AB bar plus BC bar. A bar plus C bar plus De Morgan's. A bar plus B bar plus De Morgan's. Again B bar plus C bar. Simply A bar plus B bar plus C bar. If you find any repetition, you can discard it. A bar plus B bar plus C bar. Like this. These are the basic level 1 questions from the logic gates. It's a lengthy unit. I already told you this is the initiative only. Once I am preparing for public sector, I have studied the logic gate truth table. So I want to collect all the relevant questions. I need to solve them. I need to, if I get any logical question, something different, I need to highlight it. I need to write my observations. Like that, if I find, okay, counters is very important topic. So I want to go for the counter. Immediately if I go for the counter, can I understand? No. I should learn what is flip-flop, what is a latch, how to interconnect flip-flop and latch, what type of flip-flops we have, D flip-flop, T flip-flop, SR flip-flop, JK flip-flop and so on, and what we call their truth tables, what type of trigger, I mean clock excitation has to be used in the counters, level trigger or edge trigger. If I came to know edge trigger, right, there are two types, positive edge, negative edge, how it will work like for the excitation of clock. How to find the waveforms. If I know all these fundamentals, I can I can treat the counters and logic gates as same. Both counters and logic gates are same for you if you have fundamentals, basic. If you could able to create the fundamentals in your brain, not only digital, analog, any other subject. Go through the fundamentals. If you, for example, you found there is one topic, most of the times questions are from there, and you need to understand the surroundings. Which are the fundamental topics or things for that particular main topic. You need to cover the fundamentals or basics. Then you just do attack. Spend 4 hours or 5 hours or 6 hours. You just do like a war. Simple. You can enjoy each and every moment. While preparing something, if you feel something like headache, that means you are forcing your brain. Your brain is not able to accept what you are doing. Because that training is not in a proper way. We need to train our brain in a proper way. Right? We should give the feeding properly. That's all. Okay. You try this question here. You try to solve this question. Initial, some value is given. For C is already 0. C0 means C bar value is 1. That's all. This is what? A plus B bar. Should not think what should I do, where to start. Even you should not waste 1 second of time also in exam. Read the statement, C0, substitute, options are given, so there is some Boolean expression, attack, that's all. That's all. Okay, A plus B bar. This is anyways 0, this is also A plus B bar. A plus B bar. A plus B bar plus C value 0, A plus B bar. This is AB. This is AB. What is the Y? You write it here. Y is equals to 1 dot this one x, assume x dot 1 x, it's a whole bar, right? Because bubble and plus not. So A plus B bar plus AB dot 1, of course, same thing, whole bar. You try this. Every time I am trying to stop with hint, finally I am ending with a solution. I think you can try this. See, A plus B double bar dot, this is AB bar. A bar plus B bar. Y is equals to A into A bar 0, A B bar, B into B bar 0, B A bar. That means A XOR B. But this time, I don't give you the solution. It's the last 1 minute. Just I will show you the circuit. You try it. Okay, you try this. Next question. And in the next week, in the next video, I will come up with new topic. You please give a comment, like if you want counters part, you select one topic. Because I don't know whether the students are ready to understand the concept or not without fundamentals. That is the reason I have selected very simple topic, very simple topic. So based on the majority of the comments, I will select that topic and will spend 1 to 1.5 hours in the next session, right? And you try to solve this question. You will get, I think you will get B as answer. Yes, you can do it. Okay, we'll stop here.